Good afternoon, mathematicians. Okay, today we are starting with our first step of solving equations. We are going to start basically with one-step equations using addition and subtraction. I'll kind of teach you these in small parts and then we'll pull them all together in the end. Now remember, in the last video you created a note page about solving equations. I have put it on a small flashcard just to make it easier for me. Our goal today is to isolate the variable to one side of the equation, and we have 3 steps. I will go through those steps as we begin to solve these equations. So let's go ahead and first remind ourselves about the vocabulary. Remember that an equation is a mathematical sentence with an equal sign. Now, if we take a look here, we have 3 examples of equations here. I have an equal sign, and an equal sign. Now some of these are pretty basic. Notice that this one has just constants and no variables. This one does have a variable and a constant. This one has the grouping symbols that I was talking about in step 1. Notice the undo grouping symbols. Our parentheses here are grouping symbols. Now today we are just going to work on basic equations like this one. Now, in order to solve them, remember in step 2, I told you we were going to add the opposite. What we are actually doing is working with inverse operations. Inverse operations are operations that undo each other. If I have addition, I can undo it with subtraction. So what we're going to have to do is we are going to have to identify the inverse operation. So, for example, here I have addition. The inverse operation would be subtraction. Then we're going to use this inverse operation to isolate the variable to one side of the equation. Remember, our goal is to get the variable all by itself on one side of the equation. Now I want you to think of solving an equation like lifting weights. Okay, so it's like lifting weights. You want to keep everything balanced. So if you add or subtract a number from one side of the operation, you must add or subtract the same number from the other side of the equation. So we want to treat everything the same. Whatever you do to one side, you must do to the other. Now let's go ahead and solve these 4 problems down here as examples. Now I want you to notice something here. Notice that the variable is in different spots in each of our equations. And that's okay. Our goal in every single one of these is to go ahead and isolate that variable on one side of the equation. So let's go ahead and take a look at our first one here. In our first one, we've got p plus 30 equals 22. And in this, I always draw a frame to help me keep kind of just organized. Remember, whatever we do to one side, we have to do to the other. So notice here, step 1, simplify the equation, undo grouping symbols. I have no grouping symbols. So I'm going to move to step 2, make the constant 0. Now, in this equation, my constant is 30. Notice that the 30 is being added to the p, the variable. So I want to find the opposite. What is the opposite of positive 30? Well, it's negative 30. It's whatever makes 0. So if I have 30 and I take away 30, I'm left with a 0. And I actually circle it like it's a 0 and cross it out. Now, since this is a 0, as a math person, you could write p plus 0, but why write plus 0? We don't need to do that. So it's really just p, because that one doesn't need to be written. Now whatever we do to one side though, we have to do to the other. So if I subtracted 30, I'm going to subtract 30. Now 22 minus 30 is a negative 8. Now if you struggled with that integer piece, come see me and I'll go over integers with you. At this point, notice that we have to make the coefficient 1. It already is 1, that's why we don't see it. So I am done with this problem. P equals negative 8. Okay, let's go to number 2. Notice we have D over here on the left. We want to isolate it, which means we need to turn that negative 5 into a 0, I'm going to start by doing my t-chart. I notice that I have a negative 5. What's the opposite of negative 5? That's right, it's plus 5. So I'm going to go ahead and make a 0, and it is, it's now a 0. So now I'm left with just a D. Now, if I have 19, on this side I added 5, so now I need to add 5 on this side, plus 5. 19 plus 5 is 24. Now my D already has a coefficient of 1, and so I am done. D equals 24. Okay, in number 3, let's go ahead and take a look here. Notice our variable is kind of in the middle here. We've got a constant of 2. I'm still going to do the same thing. I want to get x by itself. So I'm going to go ahead and draw my t-chart. Now, I have no grouping symbols, so I get to skip step 1. Step 2 is make the constant 0. So if I have a positive 2, how do I make that a 0? I'm going to subtract 2. They become 0, and I cross them out. Now I'm left with just x. Since I subtracted 2 on one side, I need to subtract 2 on the other side. 11 minus 2 is 9. Now my coefficient is already 1, that's why I don't see it. And I am done with the problem. 9 is the same thing as x. Now sometimes you might have to flip that, and that's okay. Since 9 is x, I can write it as x is 9. I can change it depending on what I need it to do. Now our last one. I'm going to ask you a couple questions. I want you to think about the question in your head and come up with an answer. Notice our a is in the middle, our variable. What am I going to draw to help me solve it? A t. Okay, now where is our constant? That's the negative 12. How do I turn a negative 12 into a 0? I'm going to add 12. They become 0. And I'm left with just a on the side. Now that I added 12 on this side, what do I need to do? I need to add 12 on the other side. 22 plus 12 is 34. Now, notice my constant is already, or sorry, my coefficient is a 1. That's why I don't see it. And I am done. Now, can we change this and write this another way? Yes, we can. We can change this to a equals 34. Okay, what you're going to do is you're going to turn the page, and you are going to practice some on your own. Be sure to check in with me, and we'll make sure you're doing them correctly. You got this.